Okay, so let me start with the short, brief introduction of the SSBD. So SSBD is a platform for the system science of biological dynamics researches, and that is briefly speaking, the integrated database public repository for sharing the bioimaging data and the biodynamics data. And in addition to that, this is the comprehensive platform for not only just the data, but including the tool and the environment for utilization of the bioimaging data and the dynamics data. That is the SSBD. Okay. So main part of the SSBD is the SSBD database and the repository. And so this is funded by Japanese government. And the SSBD database is the added value database for the bioimaging data, and the repository is a public repository. Okay, as you can imagine. So, and the 2 layers of the system, repository and the added value database, is based on the proposal made by maybe the first time by the Ehrenberg at the 2018 Nature Method paper, and later on the Swedol et al. By 2021. So, and this idea is to share the image data. So we have to prepare the 2 type of the repository. The first one is a public repository, and all data that published at the journal should be put onto the repository immediately after the publication. So, and for each, the experimental biologist to kind of provide the metadata for the open data. So that's a repository. It should be kept the minimum requirement of the minimum metadata. But we also set up the added value database. So that is so basically we have much more richer metadata for the each kind of the data, and those are more useful for the secondary use or for the application. So that's those 2-layer system can kind of easy to get the data, but also we get the better kind of the richer metadata. So for the better kind of open science, the environment. This is the idea. And so SSBD database actually, so we we are doing this kind of the database activity, and the wide range of the data we are accepting. And so this is just an example. So, and as you can see, that's in the imaging fields, the many data are there. So we have to take care of that. So, and thanks for the kind of community. So our database is growing, and now constituted one of the major database for this field. And so as the Mary says, that the number of the data is rapidly increasing day by day. So, and so we have the good activity right now. All right. So, but not only in Japan. So, as you know well, that the Europe country has the similar set of the public repository and added value database, as you know well. So, Empire is the database, public added value database for the EM, and so IDR is added value database for the life science imaging data, and so Bioimage Archive is the public repository for the imaging data. So, and those are well established and so well operated in European country, and accepted the data, not only the European country, but the other country as well. So, and taken together, so we are now setting up these 2 layers of the repository and added value database that we call the bioimage data ecosystem in Japan, and so European country, and accept the data from actually worldwide. So, and so we are now kind of trying to grow this the ecosystem. And so as the Mary already mentioned that we are thinking about that trying to establish the kind of worldwide system that is similarly to the DNA sequencing database and the protein kind of structural database. That is our kind of one of our ultimate goal. So, oops. Okay, so so the situation is quite a bit different from those already established database. That's the bioimaging data is quite a larger data size. So that's because of that. So we are not trying to share everything in between those repository, but basically the content of the data should be set into the original location or in somewhere in the cloud. So, and only the metadata is shared among, and so we can utilize the data by looking into the metadata. So that is our current strategy. So, and the foundingGIDE is started last year. So, and so this is already the Mario showed the strategy of our project. That's what we are aiming to integrate the bioimage archive, IDR, and SSBD data and make it kind of interoperable, or briefly speaking, searchable among these the database. So we already established those database, but so currently we cannot search among those different data resources. So the one kind of the immediate goal to be set up some system to kind of cross search all those the three image data repository, and then so the user can easily find out what they want to get. So this is our aim in this foundingGIDE, and also so we want to connect to our activity for the bioimaging data with the preclinical data that should be presented in next speaker. So, and we will make this kind of the more integrated data resources, and that is our goal. Okay, so to make it happen, so we have to harmonize the metadata in between those three different data resources. So this is, I think, one of the major or the most important component of this foundingGIDE project. So, and to do that, so we analyze and compare the existing metadata used by those three the resources, and elucidate the overlap or differences among the model, and find out map the model component and find out a way to how to harmonize this metadata set. That is what kind of trial now what we are doing. So to do that, so we ask the SSBD is ours, but the IDR and the bioimage archive, so we ask them to provide their own metadata scheme, and then to analyze what is happening there. So that's those bioimage archive and the IDR provide us the metadata scheme inside of their database, and map to those the scheme is mapped to the RIMB model that is also published in several years ago. That is currently a de facto framework of the metadata for the bioimaging data. So that's how we map each of the metadata component into the RIMB framework, and so see what is overlapping, what is not, or something like that. Okay. So this is the first result of the mapping of those three BIA, IDR, SSBD database metadata component on the RIMB framework. So, and as you can see, the green colored component is the component or kind of term shared among those three database. That is the 12 item. For example, the author's name, publication, license status or something, or the organism for the imaging or something like that. So those are 12 items. That is more easy to see these 12 items are shared among those three the repository. So that means those three repositories are developed independently. So those the 12 items are more like the important or essential, more essential, likely essential component for the metadata for the basic bioimaging. So so you can see the other several items that is not just shared among the two repository or only one the repository. So that is not only that is the completely shared the component, but each repository has its own kind of purpose or features, and depending on the features or kind of the subject, they choose their own component for their metadata. So that's so if we increase the number of the repositories, so maybe such kind of the unique featured the description or component should be increased. So that's so this is a kind of problem in our image data sharing field, but this is a reality. So we have kind of shared essential looks like essential component, but there are many the component that is the kind of the varied depending on the purpose of the repository. So this is just the item. So to integrate these the items or description, so the controlled vocabulary or so sometimes use the ontology is very important. So we also analyze the controlled vocabulary used in this the database. So this is the result of the analysis. So and we found that just only two the component or categories of the metadata. So those three repository use the controlled vocabulary, that is the imaging method and taxonomy. So and there are many kind of the component that is the only some of the database use the controlled vocabulary, but the others are using just kind of the free word or something like that. So, and more, if you look into more detail, that's there are some category of the metadata that is, for example, this case. So the controlled vocabulary used, but the different controlled vocabulary were used in some sense. That is for this case, the chemical compound and the representation, the IDR used the PubChem term, but so SSBD used the CHEBI. So that's those are used different. So they have different purpose because of that. So they choose the term for their. So that's what we should think about how to kind of integrate or connect those the controlled vocabulary different controlled vocabulary. So for the data formalization, harmonization, and also looking into the controlled vocabulary, we have another problem. That's so some controlled vocabulary require the specific license. That is typically the SNOMED CT is one of the most widely used terminology in the medical field, but it's kind of the need some licenses, and so the use of this kind of controlled vocabulary is to be restricted to the members society, members country, and so many countries doesn't have a license, including the Italy, Japan, and South Africa, and many countries. So that's a problem. So if we choose this kind of the term, so some country cannot use cannot integrate the data with the scheme. So we need to develop something that connects the SNOMED city to the term that can be used in this country. So that is another problem. Okay. So based on these analysis, that is the current state. So we try to set up the requirement or proposal of the metadata kind of the set. So just we try the use case analysis to set up the proposal. That's so we set up the several scenario, and then so what we should do with which type of the term should be used for the search key, or what kind of result we want to get, or such kind of thing. So we tested the use case related to the data retrieval and the searches, and related to sorry, that's maybe that is miswriting. So that's the data quality and assurance, and the data related to the identification management, the usability and assessment, and the use case for the data analysis. And then so find out what the metadata that's not already listed in a last table, but so we should add on the proposed data set. So, and finally, so we concluded that these 20, oops, the component should be the kind of the proposed the metadata component to be kind of used for harmonizing the three repository. That is originally that we listed up the 12 metadata component for shared in between the three the repository. So we added 8 additional component to be more useful to kind of the metadata harmonization. So that's so we don't go into detail about those kind of the component, and so we try to kind of choose the controls of vocabulary as best as we can. That's so that those vocabulary should be well kind of actively kind of updated, so and kept maintenance. That is very important. So, and we choose based on those ideas. So that's and also the widely used. So we choose those. So, and one typical example of the imaging method term, that is there is the FBBI and EDAM. That is those are very well used the ontology term. So, but so in sometimes the maintenance is kind of different. So that's this story will be explained by the later stage speakers. But so this kind of thing is very important. So we should look into each ontology or control vocabulary and the status of how those are kind of kept maintained. Or so this is very important. Right. So, and this is so our current status. So we propose those metadata component, and so we now move into the implementation of how to kind of utilize adopt this the metadata kind of set and also utilize the metadata search in between or among those three repositories. So maybe, we should take the stepwise approach. So that's it's the kind of ultimate situation will not be happening. So we propose at least the 3 steps. The first step, that's the more kind of naturally. So we should start with the metadata component shared among all 3 data resources. So that is the 12 items I listed. So that is the starting point. And the second phase that we should go into the component shared among the 2 data resources. And then, finally, we try to extend it to the wider kind of the variety of the data resources. And at that time, we should more kind of analyze to the other the repository. We should make some other kind of the priority to which kind of the component should go first and later or this kind of thing. So that's maybe we'll start the first phase within the 3 repository, and second and third phase. So we should think about the wider different repository to involve the more international kind of worldwide repository. Okay, this is the current idea. So maybe we should move on. Okay. So this is all I want to say talk today. So those work were mainly done by those 2 the researchers in RIKEN, so the Koji and the Yuki. So also we want to kind of appreciate those collaborators, that is the bioimage archive team, Matthew, other guys, and the idea, the Josh and the guide, and also the foundingGIDE, the crews. Those are very helpful, and also what we want to mention, that's the foundingGIDE international community. So that's the last October, last fall in Japan. So we have a foundingGIDE community event, and that time, we kind of presented the first draft of this metadata landscape analysis, and we get the feedback, the many feedback from the community. So we incorporates those comments into the current version of the proposal. So we want to thank those international community people. So also we want to thank the RIKEN's crew, including those guys. So okay, thank you very much for the attention. So I stop here.